Alright, number 10, we want to classify each of the following statements as true or false. A says the sum of every 3 consecutive numbers is divisible by 3. So one thing I can do to show you how this works is we can see if it's going to work for every case by using the generic form. So if I want to use the numbers 1, 2, 3, this would be an exact example. So to be generic, we'll use variables. So let's say n represents 1 or any whole number, and then we'll say n plus 1 because we add 1, that gives us the next number, and then n plus 2 would represent the third number. So this is 1 more, this is 2 more than what we originally started with, 3 in a row. If we added these 3, we would get 6, and if we divide that by 3, we get 2. So we're getting the difference of this middle number. It could be manipulated if I subtract 1 from here and add 1 here. Okay. Same thing if I were to add these 3 up together. This would give me 3 n's, and 1 plus 2 is 3. 3n plus 3. And if I divided this by 3, the way this works, we can factor out a 3 from the top. So that would be 3, and then we would have n plus 1, and then this 3 will divide, and we will be left with n plus 1. So again, the middle number. Same thing, I can manipulate this by subtracting 1 here, adding 1 here. This will give me n plus 1, n plus 1, n plus 1. So this looks like it will work every time, no matter what the numbers are. N could be any number. So we're going to look for true. Every group of 3 consecutive numbers can be manipulated so that the resulting numbers used in the sum are actually divisible by 3. Thus the sum is divisible by 3. That looks good. A statement is true. A number will always divide a sum if the sum is found using that number of terms. Okay, so we don't know that. That one's saying if we use 2 terms, it's always going to be divisible by 2, 3, 4, and so on. And that would take a lot more to prove than just doing this. So we're going to go with C for part A. And then B says the sum of every 4 consecutive numbers is divisible by 4. So we can do the same thing. We can say n is the first number, n plus 1 second number, n plus 2 third, n plus 3 is the fourth. So if we were to add all of these guys up, we would get 4n plus 6. 1, 2, and 3 is 6. If we divide this by 4, it will not divide by 4 evenly. It's the same thing as looking at this. 4n over 4 plus 6 over 4. This is divisible by 4, which will leave us with n, but this is not. We would get a fraction, 1.5, or we can get 1.5 as a decimal. We need whole numbers. So this is not, 4 numbers are not divisible by 4. Hence the previous example saying if you use that number of terms, it's divisible by that number would not be true. So false, there are 2 even, 2 odd. So the sum is divisible by 2, but not always by 4. And that would be the case. If this is even, this would be odd. This would be even, this would be odd. So the number 2 odds would be even, 2 evens would be even. That number would definitely be divisible by 2. And then we also have false. The sum will only be divisible by 4 if the result is 4 odd numbers. Okay, so it says only if it's 4 odd numbers. So let's see if that's the case. 1, 3, 5, 7. And then we also need to try even, because it said it's only going to be the case if it's divisible by odd. So we're going to do the same thing with 4 even numbers. 2, 4, 6, 8. Okay, So if we add these, we get 4 and 12, which gives us 16. 16 is divisible by 4. If we add these 4 even numbers, 6, 12, 20, and we get a number that's divisible by 4. So the second false is not true because it says only divisible by 4 if the results are 4 odd numbers, and it also works with 4 even numbers. So the false that we're going to go with is B.